given sequences, we can build new sequences that we will call series. So let AN be a sequence. Then what we can do is form partial sums. So we start with adding up the elements in the sequence. So the partial sum Sn just adds up the first n elements in the sequence A. So this sum equals A1 plus A2, etc. until AN. Now the sequence of partial sums. The sequence of partial sums is the sequence Sn. Right? And we start with the first element n equals 1, and we use infinity to indicate that we keep on going, adding up elements of A. Now this is called a series. Right? So we find different notations. It's pretty similar to what we've done and seen for normal sequences, only now we refer to partial sums, so we can just indicate the indices n equals 1 to infinity, or we leave the indices out, and this requires that we implicitly know what kind of indices we use. Or we just use the sum over AN, and this is also in green what we will refer to as the series Sn. So some examples. First example is, for instance, where we look at the sequence where we take powers of a half, right? So this is a sequence, the first element a half, the second element 1 over 4, 1 over 8, 1 over 16, 1 over 32, etc. Then we can look at the partial sums, right? So we can look at the first n powers in this sequence. Then we get the partial sum a half plus 1/4 until 1 over 2 to the power n, right? So we can depict these elements in the sum, so we can find these sums as areas. So here we take the square, which has dimensions 1 by 1. Then the first element here is A1. It's half of the area of this square. And well, A2 is 1 over 4. Then we take the upper half of the upper half of this square and divide it by 2, right? So and one of these smaller squares now equals A2. In this way we keep adding up, so S2 is the area covered by A1 and A2. And this way we can continue by adding up A3, and we keep adding up. So the remainder here is the yellow area. And what we see is that this remainder, the remainder is the area of the square minus the partial sums, equals the last element in this sequence. Yeah, so the yellow part here is equal to A3, or 1 over 8, right? So we can find an explicit formula for the partial sums, which is equals 1 minus 2 minus a half to the power n. Another example is the so-called harmonic sequence, where we have an equal to 1 over n. So then the Sn is 1 plus a half plus 1/3, etc. until the nth element 1 over n. Another example would be something that we would call an alternating sequence, and that's minus 1 to the power n divided by n, which has elements -1 plus a half, -1/3 plus 1/4, etc. So here we get Sn equals -1 plus a half, -1/3, etc. until the nth element.